Molecules are made of atoms. Individually, atoms don't have a positive or negative charge. So why would they come together to form a molecule? I made a video on electron orbitals that would be very helpful to understanding this, so go watch it. You back? You may recall that in my electron orbitals video, I explained that the shells and subshells are in their lowest energy state when completed. This means that other than this column of the periodic table, called the noble gases, all elements are not in their lowest energy state. Unfortunately, adding an electron would make the atom negative and repel the electron away again, while removing an electron would make the atom positive and attract the electron again. Thankfully, there is a way for atoms to complete their shells without changing their electric charge: covalent bonds. Covalent bonds are the sharing of electrons between atoms. When two atoms come together, their electron orbitals overlap and combine. For example, hydrogen gas is made of two hydrogen atoms. Each atom only has one electron, but a complete shell has two. When the orbitals of these atoms combine, it creates a complete shell with two electrons. Another thing that covalent bonds contribute to is the shape of molecules. The water molecule, made of one oxygen atom and two hydrogen atoms, has a bent shape. This is because of the tetrahedral structure of the sp3 hybridization that makes up the outer shell of the oxygen atom. The places that the hydrogens stick onto are these points on the tetrahedron. Also is double and triple bonds. These are bonds where either the atoms share two electrons or three electrons. The oxygen molecule has a double bond. This is because oxygen needs two more electrons to get a complete shell. For this bond, the sp3 hybridization splits into an sp2 hybridization and a p orbital. This hybridization allows a double bond to form. A triple bond is formed in the nitrogen molecule. This is because nitrogen needs three more electrons to complete its shell. This uses an sp as well as two p's to bond the atoms. Now that we've covered s and p subshells, let's cover d and f. Unfortunately, this amount of electrons contains so much energy that they will easily shed off electrons to get to a lower energy state. Also, the D and F subshells stay on the inside of an atom. This means that usually only one or two bonds are made by shedding the electrons of the outer S-type shell. This also contributes to the reason that transition metals are conductive to electricity. They can transfer electrons easily. Overall, covalent bonds allow molecules to exist, and they also give them their shape.